Hello and welcome. All right, so intermediate value theorem. I'm not going to write it at first. I want to explain it first and then write it. Okay, it's very simple. Let's suppose, just for fun, I'm just going to invent a story right now. Let's say we have the ground here. Let's say we have a building, and we're hanging out on top of the building, and there's nobody below. Right? We're not going to hurt anybody. But what we're going to do is we're just going to drop something, right? It could be a pin, rock. It doesn't matter because there's nobody down here, and this is a hypothetical situation. So, suppose you drop something, and then it falls. Yeah. Let's say this is 300 feet. Like from here to here is 300 feet. Okay, to the ground. Now, here's the thing, right? Let's suppose at t equals 10 seconds, the object hits the ground. Okay? At 10 seconds, the object hits the ground. Let's say that's the case. All right? Now, here's what the intermediate value theorem is all about. Okay? In order for the object to go from 300 feet down to 0, the thing had to pass through all of the intermediate values. Okay? In other words, right? If this is 300 feet, then 100 feet is about here. Okay? So what this means is that at some time before 10 seconds, because 10 seconds is when it hits the ground, before 10 seconds, it's at some time, it had to be 100 feet above the ground. There was some time where this had to happen. It had to pass through this height to get to this height. That's what the intermediate value theorem is all about. Okay? There was an earlier time. There was a time before this time where the thing was at 200 feet. Okay? That's what the intermediate value theorem is all about, okay? Because the thing to understand here, the thing that's important to understand, is that the path of the object that we dropped is a continuous function. So if I sketch along this curve, at no point from the time it leaves the person's hand to the time it hits the ground, at no point in this journey do I have to lift my pen or pencil, okay? So for the intermediate value theorem, we want continuity over an interval. Okay? In this case, the continuity was over this interval, 0 to 10 seconds. Okay, this was t equals 0 to 10 seconds. Okay? So if you have continuity over an interval, and then, let's see, let's call that interval in general, let's call that interval AB. So in other words, I don't know how to say it, AB. AB. It goes from x equal A to x equal B, or in this case, A would be 0, right? In this case, A would be 0 and B would be 10, right? But it doesn't have to be 0. The thing I'm trying to say is it doesn't have to be 0 to 10. It could be anything. So basically we have this. Well, let's do this. Let's say f of little a is big A. And let's say that f of little b is big B. Okay? And let's say that, we're continuous over this interval. Okay? Then here's what this means, okay? There's some number between A and B. Between A and B. So in other words, between A and B, let's put C here. We haven't used C yet. C is between A and B. C is between A and B. Okay? So here's the intermediate value theorem. I'm going to write it out. Okay? Intermediate value theorem. If f of x is continuous over an interval okay, if f of x is continuous over an interval a, b, where obviously a is less than b, then there exists a c such that c is between a and b let me get rid of, I'm sorry. There exists a c, and what I want to do is I'm going to move such that. Okay, there exists a c. C is between a and b. C is between a and b, such that is going to go here, such that f of c is, let's call it big C. And C, big C, has to be between big B and big A. Okay? So that's what the intermediate value theorem says. We need continuity. And then we need to know the values of the endpoints. In this case, f of A was 300, f of B was 0. So that means from 0 to 10, there exists some number between here. There's some time. There's some time where the height was anything that you want to pick between 0 and 300. Because it had to go through those heights to get from 300 to 0. Okay? So that's the intermediate value theorem. Okay? Let's do a quick example. They like to make these table problems, you know? So, let's say we have x and we have f of x, right? AP loves these table problems. And let's assume f is continuous. Okay, that's our assumption. And let's say we have some x values here. Something like this. Okay, so, you know, the x values are not evenly spaced in this table. Let's say we have 100, 75, 0, negative 30, negative 100. Let's say we have a big jump here, 4,000. And then negative 3. Something silly like that. Okay. So they could ask you any number of questions about this. I just want to kind of have a conversation about this because I think it'll help you understand any problem that could be asked of you. So, for example, from 1 to 2, from x equal 1 to x equal 2, the function goes from 100 to 75. If f is continuous, then that means I'm going to write some sentences down from the intermediate value theorem. So between x equal 1 and x equal 2, there must be an x such that if I plug that x in I'm going to get, and now pick any number between 100 and 75, okay? Because that's what because in order to get to 75 from 100, you have to go through, for example, 90. You have to go through 80. You have to go through 77. You have to go through 99, okay? So any of these are true because any of these are between 100 and 75. On the other hand, just working with this sentence again, we cannot say with certainty anyway that there's an x value that gives us, let's say, 74. That is not guaranteed. Okay. Likewise, we are not guaranteed to have something like 105 or 101. So to emphasize, right? This is not guaranteed. Not guaranteed by intermediate value theorem. But these, on the other hand, these are guaranteed by the intermediate value theorem. Okay? That's just looking between 1 and 2, okay? We can also look between, for example, 1 and 20, okay? So, f at 1 is 100, f at 20 is -3, so that means there's some x value between 1 and 20, such that if you plug that number into f, you're going to get any number in the world between 100 and -3 because this thing is continuous. In other words, in order to go from 100 to -3, you had to pass through 0, you had to pass through -1, you had to pass through 50, you had to pass through 20, all the values in between. Okay? Let's see. I think I'm going to call it. I think this explanation is good enough. Maybe it's not, okay? If it's not, let me know. Let me know, and we can talk about this some more, okay? Good. All right.